Well, hi, and good morning from my shop, and thank you so much for joining me here and keeping me company while I work on this radio. It's April 23rd today, and yesterday I attempted an alignment of the IF, and it didn't go so well in that a couple of the slugs couldn't be moved into the position that I think they should go in. I couldn't slide them far enough. It locked up inside the tube, or inside the transformer there. I was thinking a bit about that, and I'm wondering if this isn't a problem of colliding slugs, where there's two slugs inside these coils, and you could screw the slugs down until they hit each other. So it's easy to figure out if that's the problem or not, because all I got to do is back one out and see if the other one frees up. And I don't even know at this point if the two stuck slugs are in the same transformer. So we're going to fiddle around with that a little bit to start off with. The thing about the way the slugs stopped moving is it was very, very sort of sudden. Usually when you're reaching the limit of something like this, it's sort of, there we are, there's sort of a squeezing action going on the slug. You can think of it that way. And so you can feel it slowly binding up. It may be over a half a turn or a turn or something like that. I mean, you get a notion that you're getting close to the end. These ones, they seem to come along just fine and boom, like they hit a brick wall, like they hit another slug. So which ones is it? I don't know. I'm going to try this one here. I don't have this set on or anything. Okay, so that's a loosey-goosey. Okay, this one's hitting. Okay, so I'm going to go to the top of that one. There. Feels jammed up. Okay, so you know it's not what I thought it was, because I've got a stuck slug in the top of this one. Well, let me experiment with this. This slug hardly moves. Yikes. Okay, so whatever's going on inside these transformers is not what I thought it was, because the slug I'm moving now is getting stuck up and down in both directions. Since I'm using a metal tool here with a pretty sharp end to it, and I apply a little bit too much pressure, just about the time you don't think it's going to happen, crack one of these slugs, and then it's a whole new ball game. So okay, so we're going to leave the IF as it is. It's not properly aligned. It's close, and I just monkeyed with it a bit. I'm going to leave it like it is though, for now, and I'm going to carry on with the rest of the alignment process and see where we get to with that. We may discover some more problems. There's still old capacitors in here. Oh, there was that oscillation. I wanted to investigate. Yeah. So I think I'm gonna. Yeah, foolish of me. I went and fooled around with that thing. I left all my equipment set so we can just turn it back on and get that same oscillation and carry on from there. The heterodyne in the radio somewhere. And I kind of forgot I was doing that. Okay, now I remembered. Very good. Well, the coffee must just be kicking in. We'll get the radio going and see if we can find the same heterodyne effect, and then we're going to monkey around, see if we can get rid of it. I'm going to monkey with those slugs a little bit just to see. Can you hear it? I can hear it. It's very quiet. That's turning it off. That just has bad. That's bad. Bad, 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 bad. Anyway, radio's working. It's picking up 10.7 heterodyne. That sounds like an adjacent signal. So lots of signals in there. When the radio, when I'm tuning noise and the radio's going quiet, that could be a signal doing that. It's not just a place where there's no signals. Not all signals are modulated. Hey, what's that doing there? That shouldn't have been there. That was probably the image. Okay, find a nice... So that's pretty quiet. I'll tune the signal generator there. We'll see if the heterodyne still shows. So 11, way down here. So, let me just look at the 11. Well, doesn't seem quite right. It seems way too low. Like 11 should be a... Wait a minute. Once. 11 should be way up here somewhere. There. So wow. Hot diggity dog. So that's the image. Some interesting noises coming out of this. When I tune it right on, there's another little jingle going on in there. Now, that's because there's a signal right here. Quiet spot right there. Sort of quiet. Heterodyne? Nothing. So I think what that shows is the heterodyne tone I was hearing is really just from an interfering signal. And I found a spot where there's no interfering signal, there's no heterodyne. Very good. Okay, so alignment of the front end of this radio. So we don't start with the broadcast band. No, broadcast band here, 15600. But we start with I think the general short, the short wave band is where we start. Okay, so I'm going to set up, and we'll follow the instructions as they're laid out there. Well, I just finished the cat distraction phase of my morning shop work. And I've already realized there's a real problem with doing this alignment, and that is, the instructions say tune the radio to 9.6 megahertz. Okay, how do you do that? The dial is in the cabinet. So, okay, so maybe this is one of those radios that has to be aligned while it's in the cabinet. But when it's in the cabinet, you can't possibly align it, because you have to put a tool through these access holes into here. And you can't do that with a cabinet sitting there. So what other radios have done is they put tick marks or some kind of mark on here. They give you some hint as to where the pointer should be. And I have looked, and I have not seen a hint anywhere on here, unless maybe they're on the back side of this. Son of a gun. How the heck do you do this? Now, the way I remember my other radio that's very similar to this one, it's just an earlier model of this, there were tick marks all down the side here. There has to be something. They couldn't. They couldn't align this in the factory. Without there being some way to do it. On some radios they might tell you open the capacitor all the way, or they don't even tell you. They just give you a value. 9.6 is not all the way. 10 is all the way on that band. 9.6 is not all the way. So tick marks on here. See anything. There's nothing on the back. Some radios have round dials, and while they're out of the radio, on the back of the dial, on the back of it, is an index sheet that you use for this purpose. There has to be a trick to this. There has to be maybe something I didn't read. I don't know. I'm gonna reread the information. Maybe I overlooked something. Well, I couldn't find a hint anywhere in any documentation about this. This inside edge. How about this one? No, nothing. Nothing. How did they do this in the factory? So you see, I have the radio cabinet behind here. And I'm hoping somehow that's going to help. It's made the situation even worse in a sense. The last line on each band is in a different position. You know, like that line, that line. There's nothing consistent from band to band. Some of these shortwave radios, they'll tell you to tune to the middle, roughly, to do some of the alignment work. But usually they tell you on each band, you know, go to 7, go to 11.8, you know, go specifically. I thought for a minute, well, maybe they've set it up so you align one band and then you use the scale of the one band to find your way across the others. So for instance, you get this aligned properly. How would that even help? Well, you would know where the pointer is on this scale. Let's say we got the broadcast band aligned, and I'm able to, I don't know how I do that, but let's say I did it somehow. Then knowing this is, you know, 1200 means I can come across, this is 8.5, just come across and right on the dial here. But that doesn't, you know, that's a great idea, but I don't know how to get there. What is there going on here? Tune the radio right to the bottom. Okay, so there's the capacitor's closed there. You can see it's really at the bottom of this plate here. I'm guessing it's right at the bottom here. I mean, because one of these bands has a scale value written just above this title bar here. So I'm guessing this comes all the way. Maybe they give a range for, sometimes they'll tell you the range of the different bands, and in doing that they're actually telling you the limits. And I don't think there is any such statement in here anywhere. The limits from open to close on the capacitor. Let's say like the AM band runs from 530 to 1610, and those actually the values at the end of the tuning capacitor. No, not here though. It can't be the case, because on the shortwave band 9.6 appears right. These markings are odd too. These are odd. you know, except for the little bit of non-linearity in these numbers, you'd expect each of these bars to be halfway to the next. Pretty much halfway to the next. But when you get right down at the bottom here, that's not halfway to the next. What are they saying? So it's possible that the tuning situation with the capacitor being, it would be fully open here. At the last minute, the capacitor's response curve, I guess you could call it that, response curve, it goes a little wild. So you get 9 point. So wait a minute, so what would this be? So this is 8.5 and this is 9, and in the middle would be 8.75 they marked. I guess. I don't know what they're doing here. What's running around in my head, and I'm not really saying it, is that line 9.6. So they've left a 9.6 on there. If they've done that for this frequency, they will have done it for others too. Let's just see. So another frequency is 15.3. So we look at 15.3. Well, it's the main bar. It's the main bar there. 15.3. Let's try another one. 17.8. What's the main bar? It's in the middle. $22. It's not in the middle, but it's up here. So all those have a spot on the glass here for them. The 9.6. That's what this must be. This must be. They must have marked 9.6 there. This is supposed to. You're not supposed to stumble over this part of the process. This should be like just tickety boo and you're on your way. But I mean, the thing that's really irking me is that this is a kind of dial that you could make the radio accurate enough that you can read it right off the dial what you're tuned to. But you got to get it aligned right to make that happen. It's a quandary. It's an enigmatic quandary. Well, the sun is shining outside, and so I think I'm going to turn my attention to other matters right now and let this sit in my head for a little while and just see if something doesn't appear. Jeepers. Okay, after lots of thought and some gardening and being outside, I've decided how I'm going to proceed with this. I'm doing the alignment on here for the first time. First time through, just write it off to education. So I'm going to go ahead with it. I'm going to use a technique here to figure out where to put this dial. It's on the assumption that when this is all the way down, it's actually lined up with this very, very bottom line here. So I'm going to measure up to where I think 9.6 is. I'm not even sure where it is. I'm going to go with the idea that they marked it 6, 7, 8. Yeah, I don't know. They're trying to be accurate on a dial I can't even figure out. So, where's the accuracy there? Later when I'm using the radio, I still don't know what I'm doing with it. So we're going to call that 9.6 for whatever it's worth. There we are, 9.6. We're going to dial this guy up now from where he is. There it is. Absolutely precise. 9.6. Okay, we're going to continue on with that. Now we're going to make sure I'm on the right band. The shortwave band. 6 megahertz up here, 10 at the bottom. And what do we do now that we're there? We're finally there. So now I got another problem. It's saying use a standard dummy antenna. So there is a standard, and I hate to use the term dummy antenna. It's an interfacial circuit between the source of your signal, which is usually a 50 ohm device like my signal generator, and the antenna terminals, which are usually looking for 300 ohms, 200 ohms. They think they're hooked up to a wire out your backyard, and that feels like 200 ohms, 300 ohms. So now I actually have one of those standard circuits I made up for another radio, but in fact this box here, impedance adapter, is exactly that. And inside that box is the standard network. It's I think a resistor, a couple capacitors, or something like that. Is mine really handy here? It is. It is. It's handy if I can find it. Here, it's going to be in here. There it is. So that's a standard antenna coupling. The thing about this is its impedance varies as you go up in frequency, as you go higher bands, and that also imitates what the radio would be feeling from a regular antenna. So that's going on in my little box here. So we're going to hook this up to the antenna. There's another problem. I still don't know for sure which wires are the antenna wires. Okay, but I kind of concluded it's this one. And it says between there and the chassis. Certainly quieted things down. Oh my gosh. Wait a minute, now we shouldn't be hearing anything. The radio is tuned to 9.6 megahertz and the signal generator is running at 1 million. So what are we hearing here? Isn't that unnerving? Oh, I've got a heck of a signal being fed in. Okay, now that's more like a pretty strong antenna signal. Okay, so I think just overloading these radios generates harmonics of all sorts. Those harmonics get into the mixer tube and they just turn into some big jumble of stuff. So we want to really go up to 9.6 here. Good. So the radio is reacting at 9.4, not 9.6. Raises an interesting question. Is this really correct? I mean, the original factory alignment's still valid and this is correct and I'm about to mess it up? Where does 9.6 occur on here? Let's dial up 9.6 and we'll find it here. Oh, it's practically in the same spot. Oh, why the additional sound? Okay, so if that's the correct spot for 9.6, one of the problems with doing this measurement is I'm doing it from here. Yeah, it's an assumption. Hey, look at that. It's above. Okay, so another approach would be to make the assumption that the first band is absolutely correct, and that's 9.6, and just measure everything from this point, from wherever I think 9.6 is occurring there. Okay. Well, I'm going to go with the theory now that the radio is tuned to 9.6 properly. And all I want to do is just up it, just improve its strength. In other words, we'll stay away from the oscillator adjustment, which is the first. Oh my god, the first adjustment's not at 9.6, it's at the other end, it's 6. Okay, we gotta go find 6. But those are oscillator adjustments. Wow, they have you do these two oscillator adjustments first before doing anything else. We do broadcast oscillator. Then we come back to the same band. We do no oscillator, no oscillator. Here's an oscillator here. oscillator, oscillator, oscillator. So, oscillator and RF coils. Right, they're not actually naming the actual, they're not specifying which coil it is, they're just naming the type of coil. So, well, this is, you see why I write the first time through off? Because of stuff like this. It must be on the other sheet. Let me just take a peek on my computer here. And what I'm looking for is which are which. Yeah, it's laid out on the other sheet. I gotta print the other sheet too. Okay, let me stop for a minute and get my act together here. Boy, this radio really sounds like it's trying to receive signals from far away. So here's the other sheet, just the schematic, but the chart appears here. Location of coils and trimmers. So the first one we're looking for is going to be the yeah, so we're going to go up, try to find 6, verify if it's anywhere near there, and try to, you know, another thing is the distance. Wow, that's kind of crazy, between the 6 and the 9.6. Okay, let's go up and find the 6 first. Okay, that should be 6 on the antenna. It's definitely picking up stuff. Oh, wow, it really came off. Oh my gosh. So this could be an alignment issue. Out of alignment. In alignment. Ooh, that sounds like feedback. Okay, so there's the 6. That's a better word. Better word than feedback is the self. Yeah, you know, I forgot the word. It's a feature they used in old radios to boost. Okay, never mind all that. I won't even finish the sentence. So, do we think this is 6? Yeah. Once again, assuming the dial stops, it's a big assumption, stops right at the title bar here. Okay, where does it stop? Let's see. Up there. How's this for accuracy? Hey, that's pretty good. It's close. Now, distance between. I should be marking these. Do I have a marking? I should be marking these. So this is the 6. Just going to use the top of this. 6. Wow. Okay. We'll go down. Back down to where the 9.6 was. We'll go back up here. .6. distance between those marks. Bigger. You're gonna get this kind of like a double check. I feel like, okay, so that's the distance. What is the distance? From 6 to 9.6. It's bang on. If this line down here is 9.6. Well, it's all quite reassuring. And I don't have any alternatives. How to make it any better. Yeah, you would have thought, like in some radios, the oscillator adjustments are positioned so you can access them when the radio's back in the cabinet. The other adjustments may not be. On this radio, the oscillators are here. Some of them are here. You must come in from the front. And not only that, some of these holes you need to go through are in behind the flywheel. To take the flywheel off to do this, and that may be the case already. So what are we doing? So we're deciding the oscillator is fine. Oscillator settings are fine. So we're moving on to the next adjustment. Now we go to the broadcast band. 600 kilocycles. Cores of oscillator and RF coils. We look in here, we're going to try to find broadcast. So it says oscillator section, broadcast. That's this one here. What's this supposed to be? I guess it's this. Because there's a screw there and a screw there. A screw here and a screw there. So that's broadcast. You know what I'm going to do? I've just had a flash of intelligence here. It doesn't happen very often. I'm going to write all these numbers right on here. Yeah. I'm going to mark it right up. Okay, let me work on that. Okay, we have to get the flywheel off. I need a long screwdriver. There we go. Okay. Voila. Pretty heavy. Okay, that exposes the rest of the tuning guys. Look at the string here too. Kind of odd how they have that. Let's take a little bit of a closer look at the string here. Well, it's not odd. I just couldn't see what was happening. But I think it's climbing too high over here. It's supposed to. Oh no, it's still in the slot. There you can see how the string is designed to slide across the valley there that's been set up for it. See, it's like you would expect it to climb up onto that shaft, but it's not because the turns are sliding back all the time. So it's working just perfect. The same thing should happen this way. Good. Now I'll bet you a little lube, whatever, what's that got that's going around there? That's a locking washer. So I'm going to put a little lubrication right on the chassis there, and I'll bet you this will loosen up quite a bit. Because often the tightness in the tuning systems comes right from the shaft. Right where it goes through the thing there. I don't want this splashing around. Okay, so just be very careful. Famous last words here. There we go. Some of that. There's probably enough excess there. Work its way onto the string. Probably should have done that from the inside of the radio, not from out here. Good. So I'm going to label these now. Okay, so you can see I've labeled the holes here on the back. These are for the antenna tuning adjustments. And along here on the front. There we go. So I'm going to have to be able to swing this back and forth, more or less. Okay. The next thing is, let's get the oscillator. Next thing is oscillator, RF coils, oscillator and RF coils, 600. And then you go to 1500, and then you do the trimmers on the gang. Trimmers on the gang, where are they? So they're shown here. The gang. Underside of chassis. And I have this thing flipped up the whole time we're doing this. But these are under the chassis. I've seen these. What about the ones that are on the capacitor? Where's the hint on that? There's 6 of them on there. 6 of them. Maybe they're not used. Maybe they don't use those. Because they don't show them anywhere. What did it say again? RF trimmers on coil unit. RF trimmers on gang. Well, that's pretty clear. Gang. 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 It says oscillator and RF trimmers. So it must be the case. It must be the case. I'm not sure. So there's actually 6 sets of plates in here and 6 sets of adjustments. Well, just pretty obvious. This screw must do these small plates. This one must do these bigger plates. It's not specifying it very clearly, is it? It just says like oscillator and RF trimmers on gang. I wonder if these sections aren't all being used all the time, and what's happening is it's actually activating one set on certain bands. That would be a little bit unusual. I mean, these all look exactly the same. They look at the same thing over and over. The same thing over and over. So there's 3 sets of adjustments. There's the oscillator adjustment. Then what do they call the next one? What do they call it? I don't know if they have a name for it. RF coils. RF coils. Now where does it say antenna coils in here? Oscillator and RF. Oscillator, RF, RF. RF trimmers. RF trimmers, RF coils. Cores, coils, trimmers. So coils means oscillator coil, RF coil. So cores. Trimmers going to be capacitors. Capacitors on the gang. Trimmers, RF trimmers on coil units. So this is the one that's underneath, I believe. It says trimmers. There's only one. There's actually two trimmers underneath. So maybe this is covering them both here. Cores of oscillator and RF core trimmers on gang. Wow, you'd almost guess that what they've done with this radio is they use this section for a band or two, and then this section for a band or two, and then this. Doesn't make a lot of sense to me. I don't know. And to sort that out, we'd have to study these switch diagrams here to figure out what they're doing with these switches, and no thanks on that. Wow, I'm really yeah, I'm really stuck here. Somebody's throwing all kinds of loops at me now. The other radio, which is so similar to this, I don't remember having any of these kinds of problems with it at all. Well, you know what's happened here is the older engineers who designed the earlier radio wrote better information than the young guys who came along and designed this modern high, puppy, and didn't bother producing really good documentation. Oh, those young engineers, what do they know? What do I know? Well, I'm stuck at the moment. I got to stop for a while. I had many other little jobs to do anyway, so I'm going to stop at this point and come back at it sometime a little later in the day, maybe, when I've got some new ideas here about how to get through all this. Oh my gosh.